Welcome to another problem about the use of the Laplace transform in circuits. So this time, the problem is actually saying, assuming that the capacitors are discharged at t equals 0 minus, find the voltage V0 of t of the circuit for t greater than 0. The voltage has the form shown below. So I'm gonna basically draw the circuit first and then the voltage graph. So let's crack on. The circuit in this case is going to be given by a voltage generator, so plus minus. Here we would have a resistance. This is a node. At the top here we would have a capacitor, followed by here another node, going down here just like that. Then here we would have another capacitor just like this, and then here connecting those two nodes we would have a resistance in between, and then this side is going to be connected to the negative side of an amplifier. Okay, so it will be like this, and then connected here, and then on this end. So this hand is going to be connected to the minus of the amplifier. And here, down here, we are going to have way down here, a resistance connecting those two. So a resistance here in between. There we go, like this. And then all the way to here. We're going to measure plus minus V0, which is the one asked by the problem. This is the other side of the other part of the amplifier, and here on the positive side, of course, is going to be connected to ground, just like this. There we go. So this source, I'm going to call the source, I'll call the source Vi of t, as it's time dependent. I'm gonna call the resistance. Well, no, I'm not gonna give this a name. I'm just gonna say that this is 1 ohm. This is 1 ohm, as is given by the problem, basically. 1 farad, 1 farad for the capacitor here as well. 1 ohm here. Yeah, that's it. Just to keep everything nice and clean. And then I'm gonna draw the graph for the voltage. So the graph of the voltage is something that looks like this. Would have this one would be VI T V, and from here to here will be like this till 4, and then we will have the graph, which is 0 on this side. So this is 0 basically. It will be 1 till 4, and so this will be 1, and then it will be 0 again after 4. Okay, and this will be TS V2. Okay, so what can we say before digging into the Laplace transform? Well, this is a problem made and studied to be solved with the Laplace transform. Also because it's time dependent and the voltage has been given by a graph. So we have a step here, which is 1. So the step of 1. So first things first, we have V1 and V2, but we want to really express them as in terms of V2. So we will have that V1 is equal to, well, V1 of course, but V2, we can express this as negative V1 times T minus S. So if this is true, then we can say that the Laplace transform of ut is 1 over s. But then the Laplace transform of negative u1 times t minus s is going to be equal to negative 1 over s e to the negative 4s. Which means that v of s is actually 1 minus e to the negative 4s over s. Now, what we're going to do now is to draw the equivalent circuit of Laplace for this circuit here. So if we were to draw the equivalent circuit of Laplace, those resistances here are still going to be resistances, and those two capacitors, since they are discharged, they're initially discharged, they're just going to be substituted by resistances, which are going to draw essentially as a boxes, but I'm going to mean resistances. So what are those two? Well, this one is 1 farad, this one is 1 farad, so those are going to be two resistances of 1 over s and 1 over s. So let's just draw the new circuit here with those two swapped with resistances, which are going to draw as boxes, as I said. So the new circuit, if we were going to do that, will be, well, still have the power source, of course. This one will still be my resistance, and this will still be my node. And here I'm gonna swap this with resistance of the value 1 over s, because it's discharged. Those two are discharged, so they act like a resistance, the equivalent circuit of Laplace. So, and this one on here I'm gonna have the other capacitor, which is gonna be swapped with resistance of the value 1 over s as well, as it was 1 farad. Well, then here we will have another resistance. By the way, 1 farad is pretty big for a capacitor. Realistically speaking, it's almost never the case to encounter capacitor of 1 farad. Generally, they are microfarad or stuff like that, and don't get as big as 1 farad, honestly. But again, just to keep everything nice and clean. so it doesn't matter. Okay, so here we will still have the big fat amplifier like this to connect to the negative side, and then the positive side which is going to be connected to ground, and then here will be down like this. This will be my end, in which I'm gonna consider the V0 as just like before, and here I will have the other side, so this plus minus V0 just like before. This is the other side of the amplifier, and this is connected to ground. And this one is a resistance. So we will still have, as I said, Vi of t, time-dependent source, 1 ohm as resistance, 1 ohm as resistance, 1 ohm as this resistance. Those one are 1 over S and 1 over S, minus plus. And this is actually the equivalent circuit of Laplace for this circuit. This is the equivalent circuit of Laplace. Okay, so basically what we're gonna do here now is we're gonna apply the Kirchhoff law to each and every node. So we're gonna apply the Kirchhoff current law to those two nodes, which we're going to call node 1 and node 2. So this one is going to be node 1 and this one is going to be node 2. So node 1 and node 2. Yeah. So if you remember what Kirchhoff law says, you better do. So anyway, if you do remember it, it says that the sum of all the current entering a node is going to be equal to the sum of all the currents leaving that node, which we can also say as the current, the sum of all the current emitted at the node is 0. Now, the point is that which current are we going to have in node 1? Well, in node 1, well, we have, first of all, we have a voltage generator here, which is Vi. So it's just a matter of orientation. We can actually write everything as, I'm just going to point it out, and I'm going to write it in the other side of the page because I don't really have much space here. But basically, if you take into account the one entering the node and the one leaving the node, it will be something like V1 minus Vi, which is this current here entering the node, plus V1 plus V1 minus V0 of S, plus V1 of S, which we can write as I said. So we're going to say, whoops. Yeah, we're going to say node 1, node 1. Node 1 is actually V1 minus Vi plus V1 plus V1 minus V0 times S plus V1 of S equal to 0. Now for node 2 though, we would have V1 of S plus V0 equal to 0. So for node 2, 1. So for node 2, instead we would have v1 of s plus v0 equal to 0. Okay. So those two, if you consider the circuit here. Now, what are we going to do with those two nodes? Where we're going to put, well, with the relationship between those two nodes? Well, we're going to put them into a system, and the idea is to find v of I. So we're just going to be doing that. So let's just do this. So if we put them into a system of equation, well, we have two equations dependent, so we put them into a system of equation like so. We have v1 minus vi plus v1 plus v1 minus v0 of s plus v1 of s equal to 0, and then v1 of s plus v0 equal to 0. So this will actually give us v1, it's going to take a while, v1 minus vi, yeah, because it's, so we can just say plus, well, we can just say that v0 is equal to negative v1 of s to speed things up. So we'll have v1 plus v1 minus negative v1 of s, everything of s plus v1 of s equal to 0. So v1 minus vi plus v1 plus v1 plus v1 of s plus v1 of s equal to 0, and this is still v0 equal to negative v1 of s, and this will give us v1 minus vi plus v1 plus v1 of s plus v1 of s squared plus v1 of s equal to 0, and v0 equal to negative v1 of s. So then we're going to have 2v1 minus vi plus 2v1 of s plus v1 of s squared equal to 0, and v0 equal to negative v1 of s. So v1 of s squared plus 2v1 of s plus 2v1 minus vi equal to 0, and v0 equal to negative v1 of s. Whoops, there we go. We are almost there. So v1 will actually be v over s squared plus 2s plus 2, and v0 will actually be negative sv s squared plus 2s plus 2. So vi will actually be 1 over s e to the negative 4s. So from here we get that negative 1 over s squared plus 2s plus 2 plus e over s squared plus 2s plus 2 is equal to v0 of s. Now we gotta find the roots in order to find the poles. So let's just do this for this. So if we gotta find, we basically have s squared plus 2s plus 2. So in order to find the roots of this, we can like brutally apply delta. So p squared minus 4ac is 2 squared minus 4 times 1 times 2 So 4 minus 8, which is negative 4. Yeah, I know what you're thinking. Imaginary numbers are gonna come. So yeah, you're right if you were thinking this. But don't worry, it's gonna be fine. So we have negative b plus minus negative 4, square root of negative 4 over 2, which will give us an s1 equal to negative 2 plus square root of 4 times square root of negative 1 over 2. So simplifying is negative 1 plus I, and s2 will be negative 2 minus square root of 4 times square root of negative 1, everything over 2, which will be negative 1 minus I. Now, we have found that S1 is negative 1 plus I, and S2 is negative 1 minus I. I don't have room here, so I'm going to use another, because I wrote everything here, so I'm going to use another piece of paper. Anyway, so there we go. Let's just try to keep things visible. Okay, so we said, I'm gonna rewrite those here just to have, so we said, come on. So we said that S1 was negative 1 plus I, and S2 is negative 1 minus I. Negative 1 minus I. So now, in order to find, we have the roots, we can find the poles. So A1, we can do the same thing as before, but in this case, we're going to have s plus 1 plus I over s plus 1 plus I times s plus 1 plus s plus 1 plus minus I, I'm sorry. And we're going to substitute then the value of this one here, basically. So A1 is actually going to be given by, as I said, s plus 1 plus I, everything over s plus 1 plus I times s plus 1 minus I. So those two cancel. I will have that A1 is actually equal to 1, and then we substitute from here, we substitute the value of s with the s1. So we will actually get negative 1 minus I plus 1 minus I. I'm sorry, I was saying we substitute with S2. I was making a boo-boo. We substitute with S2, not with S1. So we substitute we put this one down, so we substitute with S2. So if we substitute with S2, S is negative 1 minus I, this one, and then we have plus 1 minus I. So negative 1 plus 1, those two cancel. Negative I minus I, it's going to be basically A1 equal to 1 over negative 2I, which is basically like saying I over 2. Then now for A2, we're going to do the same, but we're going to multiply for the other, and we're going to substitute S1 in there. So it's the same clever trick we have done all over again. So s plus 1 minus I over s plus 1 minus I times s plus 1 plus I. So those two cancel, and I get A2 is equal to 1, and then we substitute these s with the value of s1, so negative 1 plus I. So we get negative 1 plus I plus 1 plus I. So negative 1 plus 1, those two cancel, and we get A2, which is 1 over 2I, which is like saying A2 is equal to negative 1 over I. Negative I over 2, sorry. I don't know what I was saying. Okay, so now we've got A1 and A2, which are our poles. We are almost there because now we can actually say, okay, fair enough, we have found the poles correctly. So we can actually say we will have a certain pk, which would be okay plus I omega k with rho k. I'm sorry, yeah, I don't know what I'm saying. Um, sorry. So this one will be equal to -1, and omega k will be to 1. And then we would have a certain theta k, which will be pi over 2, because since they are all just imaginary, they're going to be on the vertical line of the Gaussian plane. Therefore, we would have g of t equal to 2 times 1 over 2 e to the negative t cosine of t plus pi over 2 equal to, well, this will actually be e to the negative t sine of t. So now for the other function, which is the same but translate like trust, like if I have to try to move it, it's like the same one but moved, like here, like translated like that. It will be v0 of t equal to negative g of t plus g of t minus 4 t minus 4. So I will basically get e to the negative negative e to the negative t sine of t plus e to the negative t minus 4 sine t minus 4 t minus 4, which is basically it. So it took quite some time, but eventually we got through all this. So yeah, it's not easy. You gotta remember how to find, especially, well, it's slightly different when you have complex roots. Well, basically when you find the roots and you have complex roots, and then you gotta find the poles and so on. But other than that, it's not impossible. You know, it's something that can be done. It takes quite a bit of time, especially if you are in a test and you are in a hurry, you don't know what to do, and so on. And it puts together a bit of things that you gotta know and you gotta be aware of. But in the end, it's something that can actually be done. So I hope it helps. I'm gonna be doing one more example, and then that's gonna be it for Laplace, I think. Cheers and bye.